Do 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 do. In our second video looking at forces, we're going to talk about friction and Newton's first law. So as you may have guessed, friction is a new type of force that we're going to look at. So we often will write it as F with a subscript friction. Or even simpler than that, we write it as an italicized F, and that's going to always stand for the force of friction. So you have a good idea probably of what friction is, but let's just give a definition here. Friction is caused by two surfaces in contact with each other and is a force between the surfaces that opposes motion or attempted motion. So in layman's terms, what does that mean? It means that you put two things together and friction is what causes them to not move or to move not very easily. So why that actually happens is because not every surface is totally smooth. So when you take a look at two surfaces, what happens is they end up sort of interlocking like this. So if this is surface 1 here and it's trying to go this way, and here's surface 2 and it's trying to go this way, you can see, hey, it's going to be pretty hard to get these to push past each other, right? The smoother they are, the less friction there's going to be. If something is really jagged, like if they look like this, it's going to be even harder to try to make those two move. The smaller or the smoother the surfaces, the less friction there's going to be between them. So we can actually talk about two different types of friction, and those two types of friction are static friction and kinetic friction. Not a big difference between them. Static friction is, just like the word static may imply, not moving. Whereas kinetic, if you think about our kinematics unit, anything with this prefix kin is talking about motion. So this is friction when the two surfaces are moving. The way we'd represent this is F subscript S and F subscript K. So for static and kinetic. And you may have experienced this before. It's much harder to get something moving than it is to actually keep it moving. So what does that tell us about the friction when something is stationary versus when it's moving? The friction when it's stationary is actually greater than or equal to the force of friction when it's moving. So if you've ever tried to, push a stalled car, it's a lot harder to get it going. Once you've got it going, it's a lot easier. Now, each surface that we're going to deal with is going to have more or less friction associated with it. And a measurement of that is the coefficient of friction. Basically, the higher this number is, the more friction there is going to be, the higher the force of friction will be. The lower number, the easier it's going to be to have two objects sliding along each other because the force of friction is going to be less. So the formula that we use when we talk about the coefficient of friction is mu, that's a Greek letter, equals the force of friction divided by n, the normal force. Let's actually write what all these things are. So mu is the coefficient of friction. F is the force of friction. And n is the normal force. And remember, force. N is also the unit newtons, which is when we're talking about forces. So don't confuse the n in this formula with the n for Newton. Oftentimes we'll rearrange this, and an easy way to remember this is if we isolate F by itself, we end up with F equals mu times n, or this is the fun formula. I know you think that's really fun. So we're going to use that fun formula in a couple situations. Okay, so Newton's first law, and friction is going to be very important for this. So Newton's first law is worded here: an object will remain in its state of motion unless acted on by a non-zero net force or total force. What the heck does that mean? Well, In layman's terms, or the most common way that you've heard Newton's first law, is an object in motion stays in motion, or an object at rest stays at rest, unless acted upon by another force. So what that means is if something's moving, it's going to stay moving. If something's stopped, it's going to stay stopped, unless the net force, and all net force means is all the forces all added up together, unless those all added up give us something other than 0. Okay? So let's take a look at my box here is sitting on the ground, and we have some sort of force being applied to it. You can think about someone maybe is pushing down on this box, right? They want to slide it along the floor. My kids do this all the time. Rather than picking something up, they just push it along. If they took Physics 11 and, they're 7, 5, and 2, so maybe in a few years, they would learn picking it up and walking with it is going to be a heck of a lot easier than just pushing it along. But for sake of argument, this is them pushing a box along the ground. So what all forces are there? Well, let's look at some easy ones here. So if it's sitting on the ground, what do we know? We've got the force of gravity. Gravity's pulling that box down. So we're going to have an arrow pointing down, Fg. We talked about in our last video that we're also going to have a normal force, which acts perpendicular to the surface. So that, in this case, is going to be pointing up. And we're going to label that with an N. What else do we have? Well, we have this force being applied at an angle. We don't like angles. What we like is everything at 90 degrees to each other or perpendicular. So what we can actually do is we can break this apart into its components. We can break it apart into a vector that's pushing down and a vector that's pushing to the right. And we're just going to call these F subscript y, because it's in the y direction, and this one F subscript x because it's in the x direction. What else do we have? Well, friction opposes motion. So if it's being pushed this way, friction is going to be acting this way. So we have F. And these are all our forces that are acting on here. What Newton's first law says is if we have a net force of 0, it's going to stay at the same motion. So either it's going to stay being stationary or it's going to stay moving at the same speed. In either of those cases, acceleration is equal to 0 because the speed or the velocity is not changing. So acceleration is 0. So the acceleration is 0 is because the net force is 0. Now, the way that we write net force is with this symbol. This is a summation symbol. You might have seen this in math. This just means adding up everything. So the sum of the forces, so that means adding up all the forces, is equal to 0. So that's why our acceleration is 0 here. Let's actually look at these. Let's break them up into two different categories. Let's look at the x components and the y components. So in the x direction here, what do we know? That if the acceleration is 0 and the net forces are 0, what does that tell me about all of the x directions? All of the ones pointed down have to cancel out the ones pointed up, right? So that means, left and right, not up and down. We're talking about the x direction here. So the only ones that are in the x direction are Fx and friction. And we know that if these have to sum to 0, that means Fx minus force of friction equals 0. Now, I said sum, didn't I? So shouldn't we be adding these? Now, we're going to be a little bit cheeky with what we're doing here. Notice I did not put any vector arrows on here. We're going to ignore direction for right now. So basically, we're just saying if we take this and we subtract this one, we should get 0. Or in other words, we are saying that F of x is equal to the force of friction. We know they're pointed in opposite directions, so if we wanted to write these as vectors, they would have opposite signs, but the value of them, or the number portion, would be the same. They would just be opposite signs, okay? For the y direction, let's do the same thing. We've got a couple extras in the y directions. If the net force is 0, that means the net force in the y direction, or all the forces in the y direction, also have to equal 0. Or all of the forces pointing up have to cancel out with all the forces pointing down. So what does that mean? That means that the force up, the only one is the normal force, has to equal the forces down, or Fy plus Fg. And if we wanted to rearrange this, we could say N subtract Fy subtract Fg equals 0. And again, we're doing this little sleight of hand where we're not actually putting any directions in here. We're just looking at our picture and deciding based on this, this has to equal this one plus this one, because it's not lifting up and it's not going down through the floor either. So ups have to equal downs, and that means if we take the up and we subtract all the downs, we should get 0. So our example here is a seat weighing 95 newtons is pushed across the floor at a constant speed by a force of 15 newtons that acts downward at an angle of 25 degrees to the floor. What is a normal force and what is a coefficient of friction? So what we want to do first is we want to draw a diagram. So you're going to find I'm going to draw a lot of rectangles. So my seat is going to be a rectangle. So here's my seat on here, or the chair, whatever it is. So it tells us it weighs 95 newtons. What does that mean? That is the force of gravity. We learned that in our last one. So let's draw this here. Fg equals 95 newtons. Okay, great. What other forces do we have? Well, we are being told that it's being pushed by a force of 15 newtons that acts downward at an angle of 25 degrees to the floor. So what's that going to look like? That's going to be, whoa. Cut at 1330. So what's that going to look like? That's going to be a force like this. So here is our force. We're just going to call it F because we don't know what type of force is 15 newtons. What we actually like to do, we don't like angles, so we're going to break it up into this vector and this vector. So this is Fy, this one is Fx. And that 25 degree angle to the floor, well, here's the floor. 25 degrees would be something like this. But if this line and this line are parallel to each other, that means that this angle right in here is our 25 degree angle. Okay, do we have any other forces? Of course we do. We have the force of friction opposing this. And we've also, and I've not left myself a lot of room here, we also have the normal force here. So let's do N for normal. Okay, I think we've got all of our forces on here. There's one other thing that our question says. It's a constant speed. We know from Newton's first law that that tells us if it's traveling at a constant speed or if it stays in motion and it's not speeding up or slowing down, that means our acceleration is 0. And what else does it mean? It means that our net forces are also equal to 0. So that's going to be important because that's going to tell us all our ups should equal our downs and all our lefts should equal all of our rights. Okay, so now let's actually solve out what these Fx and Fy are, because that seems, kind of important. So let's do that right away. So this is just some simple trig here. If we know this angle, this side would be the opposite, this would be our adjacent. So make sure that you get that correctly. So which one do you want to find first? Let's do, I don't know, Fy, because I looked at it first. So we're going to use opposite and the hypotenuse. So opposite and hypotenuse is sine is opposite over hypotenuse. Let's fill this stuff in. So sine of 25 degrees equals the opposite, Fy, divided by the hypotenuse, which is 15 newtons. I just need to give myself a little bit more space here. If we rearrange this, we are going to multiply by 15 newtons on this side, multiply by 15 newtons over here. So we have that Fy is 15 times the sine of 25. Make sure your calculator is in degree mode because that's what we're working with, and you should get 6.3 newtons. Let's do the same thing now for f of x, except we're going to use adjacent and hypotenuse. So adjacent and hypotenuse is going to be cosine. So cos of theta is adjacent over hypotenuse. Cos of 25 is fx over 15. And so when we rearrange that, we get fx equals 15 times the cosine of 25, which gives us 14 newtons. All right, let me just label that in our diagram here. So we've got 14 newtons and 6.3 newtons. Okay, question A says, what is the normal force? So we're looking for this one. We know that if the net forces are 0 because acceleration is 0, that means our net forces in the y direction have to be 0. So that means the ones up have to equal the ones down. So N should be equal to Fy plus Fg. So let's go ahead and solve for the normal force. So A, we just said N should equal Fy plus Fg. So Fy we just calculated right here is 6.3. The force of gravity we were told was 95. When we add those, we get 101 newtons. And we should look at significant digits here. We should probably only have 2. So that would be, that would be 100. This one's significant, this one's not. How do we show that? Let's use scientific notation. So this would be 1.0 times 10 to the power of 2 newtons. So that's our normal force here. And because we're talking about a force, we should say that this is up. We should give direction. Question B says, what is the coefficient of friction? So if we're looking at friction, we're looking at the x direction now. What do we know? Again, if the net forces are 0 because acceleration is 0, that means our net force in the x direction also has to be 0. The only ones acting in the x direction are Fx and F. They're in opposite directions, so they should be equal to each other, but opposite in signs, right? So for B, we know that Fx is equal to F. In other words, we know that F is equal to 14 newtons. We calculated that right here, right? Why did we bother doing that? Well, we're asked for what's the coefficient of friction. If we use that fun formula, F equals UN or mu n, and we rearrange for the coefficient of friction, we have mu equals F divided by N. So we calculated our, this is F. We just calculated our friction to be 14 newtons. We calculated our normal force over here to be 1.0 times 10 to the power of 2 newtons. And when we divide those, we get just 0.14. Newtons cancel out, and we are not left with a unit, which is great. I didn't mention that before, but coefficient of friction is unitless. There is no unit, so you will not lose any points if you don't put any units in there. This takes a bit of practice, so please attempt these 3 questions. There's not a lot of them. They are multi-step, and you have to really think about, and the best place to spend the most amount of time when you're doing these is making sure you draw all the forces in correctly. Good luck!